Hello, everyone. Today, I wanted to talk about 3 ways you can accelerate your work and your day using your favorite AI tools. So to get started, I'm going to hop onto one of my laptops and do a little screen recording while I do some work. As my laptop's powering up here, I just want to go over some of the things I might be sharing with you. First thing I like to do with an AI tool is use it to give me a roadmap or a plan of action for something I might want to build. For instance, this single-use token taker computer I talked about in an earlier episode. So I'm just opening up OBS Studio so I can make the recording. We're going to do a window capture. Select a window to capture. Brave. Start off with a new window. And start recording. All right, so this example, I'm explaining how to use my AI tools to come up with a plan. So I can say, I want to build a single purpose token taker, solar powered computer for local compute. I'm starting off with Sonnet 4.6. How might I go about that? I want it to use the tokens as a physical PHYSI approximation of how much power a response from an LLM uses. And I want a bag of tokens. Tokens equal to the amount of power that can be stored in the battery after a day of charging. Assume a highly efficient edge single board computer provides the local compute for this task. Let's see what we get back. And I would say here, note how I first kind of give it a summary, and then I say, how might I go about that? Then I really detail the requirements that I'm looking for, because without clear requirements, you could just be doing anything. It's architecting the token energy mapping, calibrating energy per token ratios and daily solar budgets. I'm using Claude for this, by the way. I could have tried Gemini just as well. Calibrating hardware specifications and energy cost mappings. Calibrating energy per token ratios for daily solar budget. Now, one thing about how I use AI tools is I don't like to spend too much time in a single chat. So after this one, I'm probably going to spin up a couple more chats to fully explore what kind of 3 queries I might use. All right, we have a response from Claude. It just tells me the core concept. Step 1, size the energy budget. Very practical. Set your battery to 50 watt hours and it will reach full charge on a typical day. It gave me a suggestion for the panel. Pick your single board computer. Ooh. All right. It says recommendation, Raspberry Pi 5, 8 gigabytes, and Halo 8L M.2 hat. And also gave me an alternative, the Orange Pi 5 Plus. Now, some things that Claude doesn't know. I'm actually working on building my own one of those. So probably neither of those options will be chosen. I'll be picking my own one. However, it is good. It says avoid GPU-based boards. Their power spikes destroy your token economy. And step 3, it's got calculate token back size. This is where it gets satisfying. I would agree with that assessment. All right, it's picked a model. It says The average response is 200 output tokens. Generation speed is 7 tokens per second. Query duration, about 30 seconds. Single board computer draw, 6 watts during interface. And that gives me 6 watts. It says 0.05 watt hours per query. So working backwards from that with our daily usable budget of 46 watt hours, giving it a reserve for idle time of 8 watt hours, means we have available for inference 38 watt hours. And that means our token bag could have about 760 tokens. And I actually like the idea of having 760 tokens. Claude feels that would be a big, heavy bag to give the feeling of abundance. However, it says if I run a larger model like Llama 3.2, 7 billion, I would get only 120 to 150 queries a day. So I would still have a lot of tokens, but just not quite almost 1,000 tokens. Oh, and step 4, it's included, is quite nice. It has a token mechanism. So the token slot, it hits an IR emitter, which hits an IR receiver that goes to the GPIO pin on the Pi and drops my token into the collection box. And it gave me some software logic for some pseudocode for the Raspberry Pi. Oh, and step 5, it gave me a battery plus solar wiring. And it says important, use a UPS hat between the battery and Pi, so the Pi shuts down gracefully when the battery hits 10%. Oh, step 6 is calibrating token weight to reality. It says, during the winter months, I went to reduce the amount of tokens because the battery won't be able to charge for as long. Sounds reasonable. And then it gives me a full stack. It says, your layer for the OS is the Raspberry Pi OS Lite. Inference, Llama CPP server, or OLLAMA. Gives me some model selections. It tells me to use inference, use simple curlable HTTP endpoint. Token gate is the Python plus Raspberry Pi GPIO. Power management is systemd service and UPS hat. And the monitoring is a small e-ink display showing tokens remaining plus battery percentage. And then we have some nice complimentary nonsense from Claude. So there you have it. That's one way I would use an AI system to build this concept. Now, I really want to explore the idea, so I would do a second chat and I would say, what kinds of parts should I buy or make to build a single purpose token taker solar powered computer for LLM inference to be placed around the town like they are gumball machines. Let's see what we get from that. Doing a little bit more thinking here. And it's come back with compute. So it seems really worried about the hard part, compute. It gives me lists of various small PCs. Oh, and this one's kind of funny because it has chosen the Jetson. I guess I must have forgotten. Oh no, I still said solar powered computer. So probably not the best idea. Oh, never mind. It's massively upgraded the solar panels. We now have 100 to 200 watt monocrystalline panels and a pretty big battery system. Still got the token mechanism. The user interface has had a significant upgrade. And this time it's included an enclosure, which I think is really important. Oh, and this one is planning on sending it out over the internet to actually run. So it's kind of missing a lot of what the first chat was really much more accurate at giving me an idea of how to build it. However, might as well ask it a third time. How can I build a highly efficient token-based computer? Then describe exactly what you want. I want a small beige box. Can't believe I don't know how to spell beige. With a battery and a solar panel that is able to do local LLM inference. It only powers on when a token is dropped in the slot, and then it computes one inference based on a request typed into its keyboard. There is a bag of tokens representing the daily amount of charge available for LLM inference. Let's see what we get with that kind of prompt. You never know what you'll get. One of the positive and negative things about LLMs is if you ask it the same question twice, you get different answers. You can even ask it different questions twice and get different answers, which makes more sense. But sometimes it's the same question, you just phrase it slightly differently. Oh, Claude's much more complimentary at this one. It says, what a delightful project. A physically rationed inference machine. This is part maker project, part philosophical object. Here's how to build it properly. We have the concept architecture. We have the compute hardware. And the power system, okay. Token wake circuit. Basically the same deal. No, it's kind of totally different here. It's funny how that happens. Oh no, it does have the IR beam break. And token design, it gets fancy here. It says 3D print tokens in a distinctive shape. Not a coin shape. Make them yours. That's funny because I was planning to physically smash out these tokens using a hammer and a circular stamp. I like the idea of smashing it really hard. And it gives me the software stack. Suggest Llama CPP again. And the token budget logic. Each token is one inference. Count your daily solar harvest. And here we have 100 to 150 possible inferences from day from pure solar. It does say make fewer larger tokens, maybe 10 to 20 a day, and make the tokens satisfying to hold. Heavy, distinct, laser cut acrylic, turned wood, or cast resin all work well. And then it says the enclosure, source a vintage beige PC desktop or 3D print one. Mount a small mechanical keyboard. Add an e-ink panel for output. It says e-ink is great here. It holds the last response when powered off. And then build it up. Step 7 is to follow the instructions for the build. And it does encourage me at the end. This is a genuinely wonderful project. It forces you to treat LLM inference as a scarce physical resource, which is both pragmatically useful and philosophically interesting. The tactile act of choosing to spend a token changes how you interact with the model entirely. Might be that I'm using Claude Sonnet 3.6 and it can be somewhat complimentary most of the time. I could check out Gemini some other time. So anyways, I think I've explained how I would use AI for 3 different versions of building the single purpose token taker computer. And maybe I'll build it, maybe I won't. Whatever I do, I have a better idea of how to build it now that I've spent some time querying the AI models. Let me know what you think. Thanks. Don't forget to subscribe.